Hello and welcome to the session Mechanics of Materials. So here now I'm taking a numerical problem to solve based on stress, strain and elongation. So this is the theme of this problem is to find the stress, to find the strain and elongation in a solid members. So here to have this I'm going to take a problem for you. So let us see how it's going to be solved one by one. So problem is taken here. That problem is a solid member having length. So length is given for the solid member in centimeters given with a diameter of 2.5 centimeter is subjected to an axial pull force, means that tensile force is acting on it, that is 25 kilonewton. And if a material having modulus of elasticity, means this is given, that is value E is given as 2.1 into 10 to the power 5 Newton per mm square. Okay, evaluate the value of, so here this is given, so this is dimension is given in Newton and mm. So whatever other dimensions we have, that will convert it into the mm and Newton. So here as we have this length is equal to 200 centimeter, so convert into the mm. So 200 into 10 mm is equal to 2000 mm. This is done. Then diameter we can say 2.5 into 10, 25 mm. So next here axial force is given 25 kilonewton, so we can say 25000 Newton. So this is done. So that similar dimensions need to take, so it will be easy for calculation. So next we'll move here a stress. First point is to find the stress. So here stress load per unit cross sectional area. Okay, so we have load, we have area. So area is, as we are taking a circular cross section, so area is equal to pi by 4 into d square. First we will calculate the area, pi by 4 into d square. D is given here 25 mm square, so that is equal to, so let us use the calculator to solve this, so it will be easy. So here pi by 4 into 25 square, so finally we'll get 890.87, that will be mm square. So need to be care about dimensions. Load is given 25,000 Newton, so now apply 25,000 divided by area is given 890.87, that is equal to now we can see here using calculator 25,000 divided by 890.87, so this is 28.06 Newton per mm square. So stress have been calculated here. Next second problem is strain. Second is the strain. So how to calculate the strain, that we will take up. So here strain we can calculate with the help of a formula, epsilon is equal to strain, that is epsilon is equal to stress by divided by modulus of elasticity, so that we can write sigma by E. So we have both the value. Why both the value? Because already here stress is calculated. So that is 28.06 divided by modulus of elasticity is given 2.1 into 10 to the power 5. So what is the value that we can get here? So it will be very smaller value, but let us calculate 28.06 divided by 2.1 into 10 to the power 5. So here you can get 1.33 into 10 to the power minus 4. So as this is a strain and modulus of elasticity and stress having similar unit, so this will be dimensionless. So here we can write it in a point also, 0.0000133. So like this we can write it. So 1 0 will not be there. Let us 0 1 3 3. So this is a value of strain that we calculated. Next calculation is that third is elongation. What is the elongation in the solid member? So here that elongation we can calculate. So as strain is equal to change in length divided by original length. Okay, so we have to calculate the change in length. So delta is equal to epsilon L. L is given here. L is given as, you can see in the value, 2000 mm. If 2000 mm is given and here strain also given, strain is given as, so this is the strain value we have. So just we are putting the strain value 0.000133 into length is 2000 mm. So what will be the answer? So into 2000. So answer will be 0.27267, that is 0.267 mm. So as all dimensions are in mm, here you can write it into the mm, or you can convert into the centimeter, means 0.0267 centimeter. So this is the questions that was asked. This is based on very simple formula. So as a beginners, they have very they don't have much ideas about these things. So for the practice, this question is important for the beginners, so they can know the basic concept of in the mechanics of materials, and further they can start their solving capability. So next they can go for some good questions, some conceptual questions. So this is a formula based questions. It is also conceptual, but it's directly formula based. Thank you.